Hi everyone, this is example 11 from chapter 12 in the student packet. It says, a survey finds that 33% of college students are in a relationship, 25% are involved in sports, and 11% are both. While dining in a campus facility, you meet a student who is on a sports team. For part A, it says, what is the probability that your new acquaintance is in a relationship? So before I start working, I want to write down the information that I know from the problem. So it says that, and I'm going to go down here in yellow here, the probability that a student is in a relationship, I'm going to signal that with a letter R, is 0.33. The probability that they are on a sports team is 0.25. And the probability that they are both in a relationship and involved in sports is 0.11. So this first question, what is the probability that your new acquaintance is in a relationship? Notice that when you met the student, you already knew that they were on a sports team. So this question is asking you to find the probability that a student is in a relationship given that you know they are already on a sports team. Now, unlike example 10 where I had a discrete count for everything, I don't have that here. I have a percent. So we're going to use the formula, and the formula for a given statement like this is that the probability of R given S is the probability of R and S divided by the probability of S. And we have both of these pieces of information in what we were given above. We know that the probability that they are in both a relationship and involved in sports was 0.11. And the probability that they're involved in sports is 0.25. And when we make this calculation, we'll get 0.44. The second part of this question says, are the events of a student being in a relationship and a student being involved in sports independent? So again, we want to know if one event affects the probability of the other. So we're going to choose one of these. I'm going to choose the probability that a student is in a relationship. From my information, I know that is 0.33. I now want to know if being on a sports team affects the probability of being in a relationship. So I'm going to compare this value to the probability that a student is in a relationship given that they're on a sports team. Well, we just found that in part A. That's 0.44. Since these values are different, I know that being on a sports team has affected the probability of being in a relationship. So since the probability of being in a relationship does not equal the probability of being in a relationship given that a student is involved in sports, then the events are not independent.